In this video, we'll be looking at how to solve for angles and sides using ratios and Pythagoras on the Cartesian plane. So for example 1, it says that calculate r, and we're given this sketch. So first thing we're going to do is just to construct this line at a 90-degree angle. So then we've got this right angle triangle where we can use trigonometry in. And since this coordinate, this point, this is our x and y coordinates, then for the x, this is then a length of 3. And if this is the y coordinate over here, being 5, then this length is 5 units long. So now we've got this triangle. And now to solve for r, if this is right angle triangle, we can use Pythagoras. So Pythagoras says r squared is equal to x squared plus y squared. And then to solve for r, I'm going to substitute in the values of x and y. So we've got 3 for x, so that's 3 squared plus 5 squared, and then square root both sides. So this gives us then r is equal to the square root of 3 squared plus 5 squared. And then to put that onto the calculator, we've got the square root of 3 squared plus 5 squared. So this then is square root of 34. So square root of 34. Then for b, we need to find theta. So in order to find theta, I'm going to use a trig ratio. And from this angle theta, this is the opposite side and this is the adjacent side. So opposite over adjacent, we know is tan. So tan of theta is equal to opposite over adjacent. And then to substitute our known values, tan of theta is equal to opposite, which is 5, adjacent is 3. And then we're going to solve for theta. So we're just going to take the inverse of tan. So the inverse of tan of 5 over 3. And then we put that onto the calculator. We say shift tan. And then we have 5 over 3. So this equals 59,04. So 59,04 degrees. Now for example 2, once again we have this sketch, and I'm going to construct this line to construct a right angle triangle. And our x and y values are x is 12. So over here this is 12. So this is 12 units long. And over here we've got 5 for y. So this is 5 units long. So once again, to find r, I'm going to use Pythagoras. So we've got r squared is equal to x squared plus y squared. The two shorter sides add up to get the longer side squared. Then solving for r, we square root both sides and we substitute in our values for x and y. So the value for x is 5 squared and the value for y is 12 squared. We square root that and then we type that into the calculator. So square root of 5 squared plus 12 squared. So that's equal to 13. And then to find alpha, from this angle, once again, this is the opposite side and this is the adjacent side. So we know that tan alpha is equal to opposite over adjacent. Now opposite is 5 and adjacent is 12. Now to solve for alpha, we take the inverse of tan. And we have 5 over 12. And then we put that onto the calculator. So we have shift tan. And that is 5 over 12. So this is equal to 22,62. So 22,62 degrees. Then for example 3, this one's a bit different. In this case, we've got our degree, the angle. So once again, we construct this right angle triangle. But now our y is unknown. So this is y and this is 2 square root of 3. And first of all, we need to calculate r. So we can't use Pythagoras because we only have one side. We need at least 2 sides to calculate Pythagoras. Now what we're going to have to do is we're going to use this trig ratio. And if I look at the sides, this is the hypotenuse side, and this side from this angle is the adjacent side. Now adjacent over hypotenuse I know is cos. So cos theta is adjacent over hypotenuse. So to substitute my known values, my theta now is 30. So I substitute in for theta, I say 30 in place of theta equals to adjacent. So adjacent is this 2 square root of 3. And then over the hypotenuse, which is r. So now to solve for r, r is the only unknown. So what I'm going to do is I'm going to take r up and I'm going to bring the cos of 30 down. So r is then equal to 2 square root of 3 over cos of 30. And this then, if I put that onto the calculator, I have a fraction, then 2 square root of 3 over cos of 30. So this is then equal to 4. So r is equal to 4. And then to find y, I can now use Pythagoras. So we've got b. Now, because this is the shorter side, if I write Pythagoras as r squared is equal to x squared plus y squared, to find y, I need to take the x over to the other side. So then y squared is equal to r squared minus x squared. So in short, you can just remember, if you need to find one of the shorter sides, you take the longer side squared minus the other shorter side squared. And if you need to find the longer side, as we've been doing, you add the two shorter sides squared. So substituting in our known values, we've got y squared is equal to 4 squared minus, and x is 2 to the power 2 and 3, so that all squared. Then we solve for y, so y is equal to the square root. Now if I simplify this, this is 16 minus, this becomes 4 times 3, so this is 12. And then we have 16 minus 12, which is square root of 4, which is just 2. And then for example 4, we need to find x and y. So now both of our coordinate points are unknown. So starting off, once again, construct the triangle. Then we need to find y and we need to find x. And we can just use our trig ratios once again from this angle, this known angle. We've got, this is the opposite side and this is the adjacent side. So if I want to solve for y, I'll say opposite over hypotenuse, and I know, okay, let's start with x. Let's start with x. X is adjacent, so for the adjacent and hypotenuse, we know that's cos. So if I have cos theta equals to adjacent over hypotenuse, then I substitute in my known value. So cos of 28 is equal to adjacent, which is the x that I'm looking for, and hypotenuse is 6. So to solve for x, I'm just going to multiply the 6 up. So x is then equal to 6 cos 28. And then I put that onto the calculator. So this will give me 6 times cos of 28. And that's equal to 5.29. So this becomes 30. So that's 5.3. 5.3. And then for y, so b, y opposites in a hypotenuse, that's sine. So sine theta is opposite over hypotenuse. Now to substitute in our values, we've got our angle sine of 28 equals to opposite is the y value that we're looking for, hypotenuse is 6. So taking the 6 up, I have y is equal to 6 sine of 28, and then we put that onto the calculator. So this gives us 6 sine of 28, and that's equal to 2,82. So 2,82.